Hello and welcome to another session of Groundbreakers Live. I'm your host Javed Mohammed, and we're very honored to have with us Toon Koppelaars, who is on Oracle's Real World Performance team. Toon, welcome.
Thank you, Javed. Good to be here.
Likewise. So I understand you're presenting at Sangam 2020, and you have a presentation called Core Performance Principles. So share with us what principles you're going to be talking about.
So I'm going to talk about what I often refer to as long forgotten performance principles.
Okay.
So the Oracle is a process-based architecture, and process-based architectures you need to operate them in a certain way to get the most out of them. Yeah. And one of the things that many people are not aware of, or maybe never thought about, is that whenever you call the database from an application server, you issue a SQL statement to the database. So you basically call the database with a SQL statement. Whenever you do that, you are experiencing certain overheads. So every call into the database has overheads. Okay. Of course, you have the network in the between the application server and the database server, but you need to your network package needs to arrive at the network interface card. It needs to enter the operating system. The operating system needs to wake up a process. The process needs to be scheduled on the chip, and then once it's on the chip, you still can't execute your SQL statement because you have to enter the Oracle code. And entering the Oracle code is also a little bit of overhead before your SQL statement finally arrives at the SQL engine inside our database management system. Yeah? And all these overheads are becoming noticeable when you issue certain types of SQL statements that are being issued a lot in modern applications, which is row by row SQL statements. Yeah. So modern applications, they send a SQL statement to insert a single row, to update a single row, or to fetch, to select a single row. All these, so those are really easy to execute SQL statements for the SQL engine. And by easy, I mean they execute really fast. Think 10 microseconds, 20 microseconds to execute those simple SQL statements. But all these overheads that I mentioned, they are in the order of, well, maybe 50, 60, or 100 microseconds. So calling the database with a very simple SQL statement has a really big knock-on on your elapsed time of the SQL statement. Yeah? You're basically only spending 20 microseconds in the SQL engine. But in order to get there and to actually spend and execute your SQL statement, you have already spent 60, 70, 80 microseconds to get into the SQL engine. Yeah.
Okay. So when you talk about performance, I was thinking, do you also kind of get into the fact about CPU utilization or memory or disk? Or, I mean,
Yes, I do, because the way the applications work nowadays is they call the database. Just out of curiosity, do you have any idea how many times per second the database is called by a modern application? Is it 10 times, 100 times, 1,000 times, 10,000 times? What would be your guess?
I guess it depends. I don't have an answer.
So it's almost always more than 10,000 times per second. Wow. Sometimes up to 80,000 times per second. Yeah. So so all these knock-on effects are using the CPU in
a not very efficient way.
In a not efficient way, in the way that it's not working on your SQL statements, it's working on the overheads. Yeah. And inside CPU monitoring tools, you can always watch how many sys CPU cycles are being spent by my CPU and how many user CPU cycles are being spent by my CPU. Sys being all the stuff that the operating system needs to do, and user CPU cycles actually executing code inside our Oracle executable.
Okay.
So if very often now, if you look at a database server nowadays, the chunk of time spent on sys CPU cycles is really big. You want that to be only 2, 3, 4% of the time, and then maybe 60, 70% user cycles. But often we see systems now that spend maybe 15% sys CPU cycles and only 30% user cycles. Yeah, so modern database application servers, application database servers that are being hit by modern applications, they do a lot of work, they burn a lot of CPU, but not in a useful way. Yeah? And this, in my talk, I will explain this. I will also provide evidence on that this is really happening and that it is a real measurable knock-on effect. And I also talk about how can you prevent this? How can you move away to a different architecture for your application that makes much better use of the Oracle processes that run on the database server?
Okay. So obviously, I won't have you repeat your whole presentation here, but can you just give us a sneak peek? Like, what are some of the things you can do to actually, you know, write
Well,
that are more efficient?
the big thing here is the debate that has been going on for like 20 or 25 years now in our profession, and that is, where do you execute the business logic of your application? Yeah? So in the 80s, in the 90s, we used to execute a lot of business logic inside the database, inside PL SQL, and using set-based SQL. But in the last 20 years, we have moved business logic out of the database and I'll explain why. If you move business logic out of the database, you suddenly start calling the database many, many more times per second than had you adopted an architecture when the business logic was still in the database.
And do things change? I'm just kind of curious. So when we talk about performance principles, do things change when we move from on-premise to the cloud, or is it still the same set of issues?
It's the same set of issues as long as you move all your infrastructure into the cloud. So move both your application servers as well as your database into the cloud. Because if you keep one of those two on premises, your network time will increase dramatically. Inside your on-premises data center, you maybe have a network latency of sub 1 millisecond between your application server and your database server. If you only move the database into our autonomous database cloud, but you leave your application servers still on premises, well, depending on how far away the data center is, you could now suddenly experience 3, 4, 5 milliseconds of network latency. And that directly translates into performance as the end users experience your application.
Okay. Well, it's a very important subject and a very exciting one. And we encourage kind of all the viewers out there to check it out. So Toon, thank you so much for taking the time and all the best.
Okay, thank you.